Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss some problem related to inverted U-tube differential manometer. In our previous lecture, we have discussed the theory part of inverted U-tube differential manometer. Now, we'll try to solve some problem related to this. So here I have taken a question. Water is flowing through two different pipes to which an inverted differential manometer is having oil of specific gravity 0.8 is connected. So two pipes are there in which oil is having in the differential manometer. Okay, the pressure head in the pipe A is 2 meter of water. So this is one pipe is there whose pressure head is given 2 meter. Find the pressure in the pipe B. We need to find the pressure in the pipe B for the manometer reading as shown in the figure. So let's try to understand the question first. The water is flowing through two different pipes. So this is one pipe and this is another one pipe is there. Okay, so two different pipes are there through which water is flowing and to which an inverted differential manometer is connected. So here this is the structure of inverted U-tube inverted differential manometer in which the oil is present. Okay, having an oil of specific gravity 0.8 is connected. So oil which is present in this differential manometer is having 0.8. So this actually the color should be different here. Okay, because the oil which is present here, we can say this is the structure of this, suppose. Okay, some color will be different color will be there, and the pressure head at this A point is given 2 meter. So let's find out what are the data given here. So first one, the pressure head. So pressure head, that is actually we can write pressure head equal to pressure head at A point equal to, we know the formula pressure head, that is PA divided by rho G. Okay, this is the pressure head. So that is given actually 2 meter. Now rho of this fluid, we know that 1000 we can consider density of the water, and here specific gravity of oil given, so we can write the density of oil is nothing but 800 0.8 into 1000, that is 800 kg per meter cube. Okay, and this height is given, total height is given here 30. So if this one we can consider h1, so then we can write h1 equal to 0.3 meter. Okay, similarly this is, you can consider this height is 10 centimeter, that is h2. Let's consider h2 0.1 meter, and this is given a height of 12 centimeter, so that one we can consider h 0.12 meter. Okay, now we need to find out the pressure at this B pipe. So we know that if this kind of condition is datum line given, XX datum line given, so here we can identify the pressure below the XX line, in the datum line, in the left side, we can write equal to this pressure value will be there, PA. So this is the pressure value PA minus this value will be there, rho 1 G H1. So PA actually we have not identified till now. So PA we can identify from here. So this is the PA by rho G equal to 2 given. So we can write PA equal to, okay, rho equal to 1000 into 9.81 G into 2. So we'll get near about here some 9.81 into 2, that is 19.6 to, so 1000, so 19,600 or 620 will get, 2 will be there, Newton per meter square. Okay, so this is the PA value. So we can write here PA value 19,620 minus rho 1, again here rho 1000 into 9.81 into this height is given 0.3. So here again we'll get 9810 into 0.3. So if you subtract this one, we'll get a value near about, let's calculate this, 620 minus 9810 into 0.3, 16677 Newton per meter square. So this is the value, the pressure which is below the XX datum line in the left side. Similarly, we can write the pressure, we can identify the pressure below XX datum line in the right side. In the right side, so we can identify. Similarly, what the value we can write? The PB, pressure P, we don't know that one, and this is the liquid which is flowing here. So that is also similar liquid is there. So you can write O1 G H2. The same density is there, minus this liquid, this oil which is present up to here. Okay, the oil which is present up to a height of 12. Actually, it's not given properly. So we can we need to assume that this is the oil which is present up to a distance of 12 centimeter below. So that one you can write rho S G. This H only you can write. Okay, so here you can identify PB minus rho 1. Rho 1 again 1000. We know that value, density value, because both are water only flowing here. So 1000 into 9.81 into H2, that is 0.1 minus this one rho S G. So rho S is nothing but 800 into G, 9.81 into 0.12. Okay, so now we just equalize this equation, this PA, that's pressure at this below the left side and right side. So we can write the equation what? 16,677 equal to, this is the pressure at the left side, equal to PB. This one will get 1000 into 9.81 into 0.1, so 981. So this is nothing but 981 minus, similarly we will get here some 900 something will get here, because similar value is there, only 800 the difference. So 800 into again 9.81 into 0.12, so 941. So 941. Now this value we can take it to that side. So we'll keep the PB one side. So PB equal to, we'll get 16,600 and this minus 800 something will there. This minus that side will go means plus. So 1800 plus 16,000 something will get 18,500 some value, get it. 500 or 600 something will get it. That will be Newton per meter square. That is the pressure at the P point. Okay, the pressure at the P point, what is asked in the question. So this is one type of question in this inverted U-tube differential manometer. Let's solve one more problem related to this. Okay, here an inverted differential manometer is connected to two pipes A and B which convey water. So previously we have seen the A point was a little bit down and a B point was up. Here is some slightly different reverse that is given, suppose. Now this is the A point is there and this is B point, both are given, and the fluid is in manometer oil, specific gravity 0.8, same oil is there, 0.8 for the manometer reading shown in figure. Okay, find the pressure difference between the A and B. Yeah, so here it is asked the pressure difference, that means the PA and PB we need to identify. So we can find out the pressure difference between this A and B. Okay, how much difference is there in this. So this one, let's write down this data given first. So rho S, specific gravity of oil 0.8. So density of oil we can write 800, 0.8 into 1000. So that is 800 will be there. So 800 kg per meter cube. And similarly, some data are given this side. P here we can write, which is the datum line. Okay, and this is the value of this, and this is given 30. So we can write this one, suppose h1, so this will be h2. Okay, and this is the distance from here, so total is 50. So this height will be, h height will be 20 there. Now we can write the pressure at the left side. Okay, the difference of oil in the pressure you can write, so difference of oil, write down the difference of oil equal to, in the two tubes you can write 20 centimeter. It's simple, because you see total height is given here 50, this 30 gone means remaining is 20, so that is nothing but h. Okay, so now write, directly go for the pressure at the left side. Pressure at the left side below the datum line equal to, we can write this pressure value PA minus rho 1 G H1. Okay, so you can write this equal to PA minus rho is nothing but here you can consider 1000, water is there, and 9.81 into 0.3. This is the left side actually. So left side, how much height is from this datum line, and what is the density of this for the height, and this one. So this is one pressure. Another one is pressure at the right side, similarly below the datum line XX. So that one we can write PB is there, PB minus, okay, this value, this is one, this is another one. Okay, so this one we can write rho 1, again same liquid is there, rho 1 G H2 minus this is rho G H. Okay, this is one liquid, this is another oil, another one liquid. So we can write in this way. So now PB minus rho 1, again 1000 is there, 1000 into 9.81 into H2. H2 is 0.3, again same value we will get here, what is there. Okay, minus we'll get 800 into 9.81 into 0.2. Okay, so now equalize these two equations, this one and this equation, will get PA minus PB. Let P this side, consider this side, and this term also go, let take other side. So we'll get here this value, this total value, okay, and this total value, this will be going to be cancelled. So remaining, what will the value will be there? Only this term may be there. So you can write PA minus PB. Let's solve it. That one will get something, will get like, you know, PB I have taken this side, P, yeah, this side how much will be there? 1000 to 9.81. So let me solve once. So 0.800 into 9.81 into, yeah, 1569. So 1569, final value 1569.6, okay, Newton per meter square. Very simple actually. See, this is the term which is there, and this term both are same. So if I take this side minus is there, PA minus this value, if I take that value, this value to the right side, so obviously here minus is there. Now this minus, when it will come the right side, it will be plus. So this plus and this minus will be cancelled. So only remaining part will be what? This part only will be there. So that is nothing but 800 into 9.81 into 0.2. So this value will be there. Okay, if you take to that side, so then here we can just change it, you know, this will be minus, it will come minus this value. So you can write PB minus PA, PB minus PA equal to, we can write 1569.6 Newton per centimeter, Newton per meter square. Okay, why I have taken this one? Now you can see the PB value here a little bit more than this PA value will be there. Okay, so let a difference from this PB to PA. So this is the answer. So I hope you understood how to solve the problem related to U2 differential manometer. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.